Hi loyal followers and newcomers. In this video I'll be describing basics of THC metabolism, interactions of THC with plant and drug products, and finally a genetic polymorphism, which is also considered a mutation, that may place a person at higher risk of THC toxicity. None of this presentation is medical advice, and in fact it is intended to encourage anyone using THC to exercise caution when mixing with natural or drug products. First, let's discuss THC metabolism. THC metabolism occurs mostly in the liver and is highly dependent on the route of administration, with edibles resulting in far greater metabolism due to direct transport to the liver after being absorbed. Inhaled THC has far less metabolism due to avoidance of exposing all the THC to the liver at one time. So, THC is metabolized mostly by the enzyme CYP2C9 in the liver, with some contribution of CYP2C19. This actually produces 11-OH-THC or 11-hydroxy-THC, which is an active metabolite which is similar in potency to THC itself. 11-OH-THC is then deactivated by CYP2C9 and CYP3A4 to produce THC acid, which is different from THCA or THC acid that's in the plant itself. This is a different chemical structure, but is an inactive metabolite. So the more of this we produce, as you can imagine, the less activity we have of the THC or the intermediate metabolite here. You also see that the same enzyme, CYP2C9, plays a role in both steps here. But if we do inhibit that, what that ultimately results in is an accumulation of THC, which is obviously active. We'll produce less of this active metabolite, 11-OH-THC, but then because we'll be inhibiting 2C9 down here as well, there may be kind of a balancing act, whereas we'll have less production but then less metabolism. But the net effect is we'll have less of this active metabolite as well, and then less of the inactive metabolite. So basically the whole pathway is going to get kind of slowed down and stuck at the first step, which is THC. Finally, if we were able to upregulate CYP2C9 or increase its activity, we would accelerate production of the inactive metabolite, thereby making the THC less active for that given patient that had that upregulation of the enzyme. And then you'd have a risk of lower effectiveness or efficacy if you're using it for therapeutic purposes. And that can occur through what would be called a metabolic inducer, and we will talk about that in just a moment. Now we'll get into some specific chemicals that influence CYP2C9 activity, starting with natural products, and specifically flavones and flavonols. These chemicals are found throughout a large variety of plants. Several have actually been shown to inhibit CYP2C9, with the highest potency inhibitors listed here. I've actually put them in rank order, with the strongest inhibitor ranked at the top here, which is called galangin. Now I need to briefly explain what Ki means. Ki is a measure of how strongly the chemical binds to and inhibits the enzyme. The lower the Ki, the less chemical it takes to inhibit the enzyme, and that means higher potency. Therefore, if we look at the table here, we would expect galangin to be the strongest inhibitor in this group, and its Ki roughly means that it can inhibit about half of CYP2C9 activity at a concentration of 0.15 micromolar, which translates to about 40 micrograms per liter of fluid. That's actually very impressive for an enzyme inhibitor. Perhaps the most interesting thing to me is the fact that galangin is a chemical that I just became aware of that is found in galangal. And galangal, you may not be familiar with that unless you like Thai food and maybe some other Asian foods. But galangal is a root like ginger that I like it because it's used in one of my favorite soups, which is tom kha gai, which is a coconut chicken mushroom and lemongrass type of soup, and actually is lime as well. So that's really a unique soup that has quite a strong flavor from the galangal. So that would be the one source of it, food source that I'm actually aware of. So other foods/herbs that inhibit include capers. Now let's be honest, who actually likes capers, especially because they come in such a sour kind of sauce or fluid, which Maybe that's natural for them, but I'll eat them if they're there, but I don't know many people who like them. And then parsley and thyme, believe it or not, something as simple as parsley has a fair amount of, in this case, apigenin, which is another chemical in this group of basically flavonoids. And then we have a lot of other things as well that you can see on here, which I won't get into. And by the way, anyone who's kind of interested in the chemistry, this is the basic chemical structure of a flavone. Now, if you start adding hydroxy groups on here, you'll start to produce flavanols. And really, all these chemicals have this basically have this chemical backbone or structure with all the variations on it. So they all have this common structure here. So they're not that diverse, other than the fact that they have different positions for the hydroxy or OH groups. Now, to know how likely these are to cause THC toxicity, we would really need to know the percent food mass made up of the chemical, also the fraction absorbed when consumed, which is called the bioavailability, and then the total quantity of food consumed. That's at a very minimum, just to kind of scratch the surface of understanding what the real risk is. So it's actually somewhat complex to predict because it's not just about the potency that we see here. Again, it's about how much actually gets into the liver at the same time as the THC, which, right, that's going to be dependent on when you take the two different things. So it's very complex, actually. Okay, so what about the drug's ability to affect CYP2C9? So not natural products anymore, actual medications. Well, you can see here that many drugs are known inhibitors of CYP2C9, but this is only scratching the surface of the known drugs interacting with it. So I would expect the majority of these on this table to have clinically meaningful interactions with CYP2C9, since we already know these drugs can cause toxicity of other medications that are metabolized by CYP2C9. Interestingly, we have seen that ethanol, in beer, wine, liquor, etc., ethanol can induce CYP2C9 when used chronically. So alcoholics may possibly metabolize THC faster than normal, leading to actually lower effects in those patients. This comes with the caveat that liver damage may override any enzyme induction eventually and prevent metabolism altogether if cirrhosis sets in. So anytime you have something like ethanol that induces an enzyme, again, you have to always remember that if someone progresses to full liver failure, well, really none of those enzymes are going to be meaningful anymore or functional anymore because you're not getting blood flow through the liver. So in the interest of time, I'll skip over the other drugs, but I imagine some of these are probably familiar to a lot of you. Before I wrap up the presentation, I'd like to discuss a related issue with CYP2C9, and that is pharmacogenomics. Pharmacogenomics is the study of how genetic differences between people affect response to drugs. So by convention, the most common allele, which is the gene sequence that is found in a population for a given gene, is given the *1 designation. So if somebody has *1/*1 after the gene name, that means they have both copies of the gene, or both alleles, are the most commonly found sequence in the whole population, or we'll say the normal sequence. Okay, anything other than *1 is less commonly found as a sequence in the population. We know for sure at this point that if you have the CYP2C9 *3, that means you have two copies or homozygosity in this sequence, which is abnormal. You get a much lower CYP2C9 activity, and then any substrate or any drug that's metabolized by CYP2C9 might then get toxicity or an increase. Okay, at least an increase in the chemical that's supposed to be metabolized. In this case, it's THC. So yeah, so if you have that genotype, there is evidence that you can have literally 3 times higher exposure to THC. And that's not technically the concentration, but something they call the area under the curve, meaning if you plotted THC concentrations throughout the whole, after one dose, and then watch the concentrations throughout the entire time after that dose until it's gone from the body, If you integrate the area under that plot on the chart, that's called the area under the curve. It's an indicator of the total exposure to that chemical. So we get about 3 times the exposure to THC, again, if you're homozygous for this *3*3 mutation. So that does mean they produce less 11-OH THC, but that means it will take them longer to get to the inactive metabolite, which is THC-COOH, which basically translates, again, to THC toxicity. And this is what it kind of looks like. So again, the enzyme is mutated. We get a buildup of THC, less 11-OH. Even though that is active, we're lowering that. It's kind of overshadowed by the fact that we're elevating THC anyway, which is at least equal activity as the 11-OH. So we do get a higher risk of toxicity. And basically, another way to look at it is it's taking us longer to get to the inactive metabolite. It's taking longer to shut off this activity. Now brace yourselves as I show a little of my affinity for PowerPoint transitions and animations. I'll be showing my rendition of what a patient may feel like when they have THC excess. That is, they may have panic attacks and in some cases even hallucinations. The reality is this is really no laughing matter for a person who has a baseline anxiety disorder or an anxious mind to begin with. So it's definitely something you may not consider a real toxicity because it's not damaging an organ, but it is creating a fear in that person potentially if they have that excess THC. So it's a very serious issue. So here we go. So I hope you survived through that journey, and I hope I didn't stir up any bad flashbacks. Now, of course, there will be other side effects of excess THC, but I'll leave that for another time. Thank you for watching, and please consider subscribing and commenting. And have a great day.